So we're still looking at the TypeScript language. We really only barely started it the last day, so let's try and get through that as quickly as we can. And all we know about TypeScript at the moment, from a syntax point of view anyway, is that we declare a variable's type by using this postfix syntax, which we are illustrating here. And we use that as well in functions to declare the signature of a function. Then, okay, it has classes and interfaces. Then we talked about interface data types, which is a way of really defining your own custom types for the types of data structures in your application. And this is the syntax for that. That's kind of where we left off, really. So we didn't get that far. The next term is what are called type aliases. Type aliases and interface data types, they overlap, but there's a lot more to type aliases that you cannot do with interface data types. In terms of the overlap, if we look at the actual examples down here, right, what I'm doing down here is I'm defining a type called point, sorry. And really, it's the structure of an object. But that's what we were doing with interface data types. So that's where the overlap between type aliases and interface data types occur. Not sure why the designer of the language allows us to do both, but there you go. There's a slight little gotcha in the syntax, like there's an equal sign here, whereas when we look at interface data types, there's no equal sign. But other than that, they're identical, and you can interchange, and that there's absolutely no difference between using a type alias in this way and an interface data types, and they're completely interchangeable. However, there are lots of other things you can do with type aliases that you cannot do with interface data types. I mean, technically, if we abstract up a little bit, all a type alias is, as the name kind of suggests, a type alias allows you to define a name for another type, right? An alternative name, if you like. That doesn't really help us. It's when we start looking at use cases of type aliases that we start build up our understanding of them. I have two other use cases here, and I will come back to them again, but we'll just cover them now. See, what I'm doing here is I'm defining a type called alphanumeric. And the way you interpret this is a variable of type alphanumeric could be a string or it could be a number. And we've got two examples here where I'm declaring variables of type alphanumeric. Admittedly, now alphanumeric is not a very useful type, but I had to come up with something. So num here is of type alphanumeric, and I'm assigning it an actual number. From a type syntax point of view, or a type safety point of view, that's okay. I'm defining another variable here, and I'm assigning it a string. The underlying here is just it's just a VS Code thing telling me that, look, you've declared a variable and you're not using it, so it's got nothing to do with TypeScript. So that's another excuse me, that's another use case of typing. So this is what we would call a type alias declaration up here. Another use case here is where I'm declaring a type called pet category. And I'm saying that a pet category variable can only have one of these three values, nothing else. And so here I'm declaring an actual variable of type pet category, and I'm assigning it the string cat. So that, from a type safety point of view, the TypeScript compiler is happy with that. And we'll see one or two other use cases of this type aliasing syntax. It's very powerful, actually, as we work our way through these slides. Now, so if we had to declare explicitly the type for every single variable that we use in our code, just from a sheer volume of syntax. There's a lot of, as we call, a lot of extra noise in our code in order to do that. This postfix syntax. But fortunately, the TypeScript compiler will infer the type for of a variable for us. And in many cases, in most cases, it gets it right. Some small few cases, it may actually get it wrong, and we have to be explicit about the type for a variable. So this type inferencing is something that the compiler does behind the scenes. It infers the type. And you might remember, if you look back through the slides, the comment from uh, Bernard Eich, the creator of JavaScript. That was one of his comments about the TypeScript language, something that he liked about the TypeScript language, the fact that type inferencing was kind of built into it. Just to give you a simple illustration, if we go back to, let's see, something as simple as this. Like here in this line here, I don't actually have to tell it that this variable is type string. I can actually get rid of that and it will infer it. Now, how do I know it has inferred the correct type for this variable? Well, in VS Code anyway, there's a keyboard sequence, Command K, Command I. And so if I do that here, so Command K, Command I, and what the VS Code is telling me is that this variable, its type is string, but it's really the TypeScript compiler now has inferred the string type on this variable for me. And so it infers it just basically based on what you've assigned to the variable. Now, it's very obvious in this case. We've actually, it's an explicit initialization of this variable. But if this variable was assigned another variable, and that other variable was assigned its value from some other, maybe calling a function, and the function returned, a Boolean, then the type inferencing would follow all the way through to the variable in front of us, and it would infer that its type is Boolean. So anyway, so type inferencing is where the compiler infers the type for us. And what you'll find is that as you become more and more experienced with TypeScript, you'll find yourself explicitly declaring the type less and less. But it's always a good idea to use that keyboard sequence, Command K, Command I. Although on a Windows machine, I think it's probably Control K, Control I to check that the compiler is inferring the correct type. So that's type inferencing, and it's quite powerful. Like it follows all the way through, and I'll show you one or two examples of that later on. And the benefit I'm saying down here, the benefit of type inferencing is, okay, you as a developer have less physical keyboard typing to do, so your productivity increases. Let's talk a little bit about functions. I think I meant to mention it briefly though. So with a function, you have to declare the types of the parameters, and you declare the type of the return value for a function. Although in most cases, you let type inferencing work out what the return type is. Really, all the compiler does is it looks at the return statements in your code to work out what type the return value is. So quite often you can leave this bit out, but again, use Command K, Command I to make sure that it's inferring the right thing. So from a syntax point of view, that's how we do it. And I'm saying here, compiler can often infer it. That's okay. Let's have what's next? Sorry. No, let's do a quick look. What will I do? Let's see. No, let's stick with the slides. Yeah, so there's nothing terribly interesting. That's all fairly obvious. Higher order functions, as you know from your JavaScript studies, a higher order function is a function that takes a function as a parameter. And so from a TypeScript point of view, the question is, how do we declare the type for that function parameter? Generically, we refer to a function parameter as a callback. So I've just got a kind of a very makey up example here, right? So I've got a function called to print to console. It takes a string, excuse me, and the second argument is a function. Now, okay, I've used the generic name for the argument here, which isn't great, but that's okay. So here is the syntax for how you declare the type for a function parameter. And by type of a function parameter, I simply mean the signature of the function. So we're saying that the callback argument, it has to be a function where the function just expects one parameter of type string, and it returns a string in this case. And we're using the JavaScript arrow symbol rather than like we're not using the double colon here in string. We need to use the arrow symbol. So that's just from the syntax point of view. There are lots of functions that would match that signature, but from TypeScript point of view, all it will check for you is to make sure that whenever you do invoke this function, that the callback argument that you pass to it, at least that function does honor or respect this signature here. Doesn't really matter what the function does in this case. Just in passing, sometimes functions, they don't return anything. They don't actually have an actual return statement. Now, we can say in that case that the return type is void. Void, you might remember, is one of the primitive types built into the TypeScript language. Okay, you can use type aliasing to improve. Yeah, let's look at some actual code now, maybe. So this code that I'm working my way through, you can get at this from, I think I mentioned this last week anyway. So, oh yeah, one thing I didn't mention last week, just kind of silly really, but like how do you run? So these example files that I'm looking at, they have console log statements in them. How do I actually run them? And to run them, you go npx ts node, and then you give, the name of the file. So let's supposing I want to run the basics one, which was in my case 00 basics. I can type in the index.html, index.js if I want to, but you don't have to. It'll assume that as a default. And okay, these are just the console log statements that were in that particular file. So what's happening here is TS node, that's a binary utility. It's taking your TypeScript file. Remember I said to you the last time, TypeScript is not a runtime language, it's only a compile time language. So it's taking your TypeScript file, it's compiling it down to JavaScript, and then it's running that JavaScript on the Node platform. So it's doing all of that in one go. And clearly that's only something you would do during development. If you want to deploy this code to the cloud, let's say, you would compile it down to JavaScript and then upload that to the cloud. If you just want to see what the JavaScript is like, then you compile it. And so in the case of here, there is a utility called TSC for TypeScript compiler, presumably. And if I hit return, and if I look up in my 00 basics folder, you can see there is an index.js here. So that's the JavaScript equivalent of my TypeScript. And if you looked at it, and really there never is a need to, but if you look down through it, you will find that all of the Uh, the TypeScript postfix annotation stuff, all of that is gone. All of the type related uh, syntax that we had in our TypeScript file, that's now gone, obviously. So this is pure JavaScript. Anyway, back to functions. Uh, they're all okay. They're simple. They were in the slides, so we need to talk about them. We know the arrow function was a nice feature introduced in JavaScript. How do I use that? How do I use TypeScript for arrow functions? And so that's what I'm showing you here. So I've got this fairly useless function called add strings, but I'm using the arrow syntax. So add strings takes two arguments of type string. It returns a string, and then we have our arrow. We've got our arrow function declaration. I'm assuming you know now that in JavaScript, in JavaScript arrow functions, if you omit the curly braces, because I don't have any curly braces in closing the body of this function, if you omit those, sorry, first of all, you can only omit those if the body of the function just consists of one statement, which it does in this case. That's my thing. That's a single statement in the body of my function. This is all JavaScript now. And if you don't stick the returns, sorry, if it only has one statement, if the body only has one statement, then that automatically becomes the return. The evaluation of that statement becomes the return value for that function. We don't, and in that case, you don't need to explicitly use the return statement. So I don't have an explicit return statement here, but because this is a single statement arrow function, and I've left out the curly braces, then it is returning the evaluation of this statement, which is a string, of course. Which kind of tells me that I could probably leave that out. And if I here do Command K, Command I, you can see there on the right, it's inferring that the return type is string. It is using the arrow again rather than the colon, but that's how you interpret this from Command K, Command I. So that's another illustration of type inferencing, in this case in relation to a function. A lot of the examples here, they're straightforward kind of things. You don't really need me to talk through them, but this is just another made-up example. I've decided I want a function that rotates a string around its axis. That's the objective, right? So this rotate function, it takes what I'm calling the kind of the source string, and it takes an axis, and the axis can either be specified as a string or a regular expression. I'm assuming people have used regular expression somewhere along the line. Where if it's a string, then what this function is meant to do is it's meant to look for the axis string within the source and then rotate the source string around that axis. If it's a regular expression, then it essentially looks through the source string for a match, the first match of that regular expression, and it rotates around that part of the source string. Now, I'm not going to talk my way through the code, it's just JavaScript code. But I suppose the only thing here is that the idea that here I've got a parameter and I'm saying it could be a this or a this, it could be a string or a that. Clearly within the body, like I have to work out, well, is axis, was the particular invocation of this function Was the access specified as a string or a regular expression? That's what I'm doing here. I'm checking to see what type is access. Type of there, as you know, that's not a TypeScript operator. That's actually a JavaScript operator. So I'm checking what kind of primitive type is access. Is it a string? If it is, then do this processing. Else it's a regular expression and do this processing. You can go back and look at that yourselves. And here I'm invoking my rotate function just to make sure it's working. I'm doing some console logs. Sorry, here I'm invoking it and doing some console logs. You can go back and look at that yourselves. Okay, that's all right, I think. In terms of higher order functions, just an example. Let's see. That's a trivial enough example which you can look at yourselves. I think that's the one that was on the slides, actually. Yeah, let's look at this one. So I've got this function called array mutator, and the idea is you pass it an array of numbers and you pass it a function whereby the role of the function is to mutate or change each of the numbers in the array change them in a particular way. In other words, kind of pass the number to the function, and whatever the function returns, the function is meant to return a number, and that number is put into the kind of the output array. So we were mutating this source or original array. But from a TypeScript point of view, the second argument here is a callback, and I've given it a meaningful name this time called ranker. And here I'm saying that the ranker function, it has to be a function that takes a number and return a number. And there are probably lots of functions that would honor that signature. And the body of the function, all it's doing is it's mapping over my source array, invoking the ranker every time. Sorry, invoking the mutator. Did I call it ranker? Mutator, sorry. Invoking the mutator every time and returning the result of that mapping operation. So, yeah, so there's a nice kind of slightly more realistic example of a callback. And I'm calling my array mutator, passing an array of numbers here. And here's my actual mutator function where looks like I'm multiplying each entry by 10. And do I have another? Okay, here's another example where this is actually going to be another kind of mutator. In this case, the mutator checks if the number is greater than 100, and if it is, it decrements it by 10%. Otherwise, it leaves it alone. So the signature of that selective mutator, as I call it, the signature of that function would satisfy as a mutator for my higher order function up above, and I'm calling it down here to prove that it works. Again, you can run these things if you want to clarify your understanding. Back to type aliases. So, when we look at that, let's see, where is it? Okay, my mutator, sorry, where's my mutator? There. The mutator function signature, it's quite short. To take a lot of effort if you like to read it. But, if you can imagine if the function had 5 or 6 arguments, then just from a code readability point of view, you kind of have to read through all of the arguments and try and get an understanding of what the role of this callback is. It would be nicer if we had a snappy kind of name for the type of this function and then use that instead of putting the actual signature here. It's just purely from code readability, right? And that's what I'm actually illustrating down here. Uh, where's it gone? Here, right? I'm actually declaring a type called mutator function. And what I'm assigning to it is the signature. That now means I can use this in my array mutator up above. And rather than going back up and changing it, I've decided, look, I'll declare a new function called array mutator 2. Has the exact same signature, but here I'm actually using my custom, my type alias definition. And really the whole point is to improve the code readability. Not a whole lot gained in this example, but I'm sure you get the point. And it's also an illustration of another use case for type aliases. Okay, I'm not going to bother with that. Back to my slides. So that's higher order functions. When you've got an object structure, sometimes some of the properties in your object structure are not mandatory, they're optional. So TypeScript has this optionals feature. And again, if we see an example, so I'm using it here with an interface data type, but I could use it with a type alias as well. So I'm defining a user type, and I'm saying a user has to have an ID property and a name property. And here, the question mark here is a TypeScript symbol, and it's saying that the email property is optional. Its type is that. I've got a social property, which is also optional. If the social property is present in an actual user variable, then we're saying it has to have a Facebook property, but it may or may not have a Twitter property, and it may or may not have an Instagram property, because I'm using the optional symbol down here as well, and it has to have a status property. Again, that can be quite useful. You can also use this optional character in function signatures if you want some of the parameters to be optional. I thought I had an example over there, but I don't. There are some constraints though in that your optional parameter, I think you're probably only allowed to have one optional parameter in a function declaration, but the optional parameter has to be the last one in the parameter list. It can't be anywhere else, otherwise the compiler will complain. And clearly, if it is optional, then you've got to make sure that in the body of your code, you're not assuming that it's always going to have a value, because when it's not there, it's going to be undefined, and that can cause problems in your runtime. But that's something that, well, I was going to say that's something you're going to have to take care of. But really, the compiler, if it sees you using the optional parameter, if it sees you using it in a way that you are assuming it will always have a value, then the compiler will actually catch that and it will throw up a compile time error. Let's have a quick look at some code back on in relation to all of that stuff. So that's our user that we had on the slides. And here I've got some actual user variables. So Joe does not have an email. It does have a social, all right. And so because he has a social property, there has to be a Facebook within that. And it doesn't have a Twitter or an Instagram. Jane has an email and doesn't have a social property. There's no complaint from the compiler. It's happy that that is a valid user object. There's no red squiggly lines. Jill has an email and does have a social property and has all of this. So they're all valid. Those three are all valid user objects, even though there are slightly different shapes to each of them. But they're all valid because we use the optional symbol in our user type declaration. What's going on here? Oh yeah, here's a function, and we're saying it takes 3 arguments, but the third one is optional. And as I was saying there, if I just reorganize these, if I move that up to be the second argument, you can see I'm getting the red squiggly lines here, which in VS Code is the compiler complaining. And it's complaining because there is an optional parameter appearing before this mandatory parameter. And so it doesn't like that. And here I'm invoking my function. In this case, I'm giving it only 2 parameters, but there's no complaint from the compiler. Here I'm giving it 3. So it seems to work okay. All right, back to the slides. Back to type aliases. These are 2 more use cases for type aliases, and they have specific names. There are what are called union types, and there are type literals. A union type, an example of it is here. We actually saw that a while ago, but I didn't give it a name. So size here is what we would call a union type, as in it is made up of the union of, in this case, 2 other types. They don't have to be primitives. They could be custom types, in other words, interface data types. And it's not limited to 2. So I've got this size type. Here we've got a variable called glass size. It's of type size, and I'm assigning the string. So that's consistent with here. I've got another variable called bottle size. It's of type size. I'm assigning 2.5. And the compiler is happy because of this. Now, clearly in this case, in these 2 variables, it's not going to, type inferencing won't really work, because if you leave out size here, it's going to infer that the type for glass size is string. And we don't want that. We'd like it to be more specific. We'd like it to infer that its type is size, but it won't, it's not clever enough to work that out. Similarly, down here, it wouldn't work it out. Here's another example of union types. So I've got a type called role, and I'm saying it could be a student or a lecturer or a manager. And presumably student, lecturer, or manager are types that we've defined somewhere else using either interface data types or using type aliases. Let's assume this was defined with an interface data type. And as I said to you, interface data types and type aliases can be mixed and matched. And here we are mixing and matching them because we're using it in the context of defining a type alias. Here's an actual variable. So Jane is of type role, and whatever the properties of student were, let's assuming that's what we had here. Again, from a type inferencing point of view, the compiler would not be able to infer that Jane was of type role. The compiler probably would it probably would infer its type as student. I'm not sure if it would even get that right, but it certainly wouldn't infer the type role. So that's union types, examples of union types. Type literals is where you're defining a type, but you're constraining it to specific values. So as an example here, I've declared a type called the degree nomination, and I'm saying the only valid values for a variable of this type would be either be a C or this or this or this. Here I've got an actual variable of type degree nomination, and assigning it that string, and because that's one of my literal values, then the compiler is happy with that. Let's go back to the code. Let's see. Okay, let's take it from here, right? So this is a bog standard type alias. I've defined a type called social handle. I've defined a type called address. I've defined a type called contact, which could be of type social handle or address. I have a type now called user v2, and of particular interest is a user v2 has a contact property whose type is contact. So it could be an address or it could be a social handle. I've got an actual variable here called Kyle. Kyle has, in terms of his contact, the contact looks like it matches up with the social handle type that I defined above. I've got a Jenny variable of type user v2. Her contact, though, looks like it is of type address. And so the compiler is happy with all of that. I've got a function here called getContact, and the idea is you pass it in a user v2 object, and I want it to return a string where the string is a kind of a serialized version of their contact. Okay, that's what I dreamt up for myself. So my implementation is here. Now what the implementation needs to do is it needs to work out there's a particular user that's passed in. Does that object have an address contact or a social handle contact? Because the output is going to be, the return value is going to be slightly different. Yeah. And this is how I'm doing it here. I'm actually checking to see, in this case anyway, I said I'd use street. I'm checking to see, is there a street property in user.contact? And we know from looking at it that if it does, then that must mean that the contact for this particular user is an address. Yeah. But the compiler actually can work that out as well. And so the way I can prove that to you is that if I do a control command K command I on this variable here, because I'm assigning user.contact to it, if I do that, command K command I, you can see that it is inferring address. So what's actually happening is the compiler is following the flow of execution in my function, and it has worked out that this is really of type address. It's not saying, oh, it's of type contact, and it's not making up its mind whether it's an address or a social handle. It has actually worked out at compile time that its type is address because of the condition statement that I have here. That is referred to as type narrowing in TypeScript, as in the compiler has narrowed down the type for a variable by simply following the flow of execution in your code. So, it's kind of clever in that sense. Equally, down here, because I do have a return statement here, then the only time that the flow of control is going to get to this line in my function is if the contact is a social handle. And again, if I check that by doing Command K, Command I. It has worked out that it's a social handle structure. And like the benefit of, if you like, of all of this, and I didn't mention this the last day, but if I just do something here, right? If I go let TW equals contact. Now, when I type dot here, see the way it's telling me, look, the only options that you can meaningfully use here are these ones. You can't go dot street because that doesn't make any sense. And if I did, then the compiler would straight away say there is no street property in the contact variable at this stage in your code, at this particular point in your code flow. So that kind of IntelliSense that's built in when you're just writing your TypeScript code can be very beneficial so that you don't start trying to access properties of objects that don't exist, which in the JavaScript world, I keep saying this, but in the JavaScript world, that's what happens. And it's not until you run your code that it throws up an error eventually, and you kind of have to backtrack to work out what's causing it. And it's often because you try to reference properties in dead objects, reference properties that don't make sense. Okay, that's that. So that was just in passing there, this idea of type narrowing that we came across. An example of literal types. I've got a literal type here called department. It could be engineering, or sales, or accounts. I've got a user v2. I'm declaring a type called, staff member. This is just a nice kind of trick that you can do as well. So I'm saying a staff member is made up of all of the properties of user v2, and I'm adding in some additional properties as well. Only one in this case though. So there's a department property and its type is department. And what else? I've got a company structure here, which is an array of staff members. And here I'm just creating the array for myself. I'm using the user v2 objects that I defined earlier on. Jenny and Kyle. I'm using the spread operator, which we know from JavaScript. And I'm adding on my department property. So that all looks to be in hand. I've got a get contact. I've got a get staff names function here where I pass in an array of staff members to the function, and I also pass in a department parameter. And what it's meant to do is find the names of the staff members that are essentially in that department. But I only want their names. And so here's the implementation. So I'm filtering over my array of staff members first to pick out the ones in the correct department. And then I'm using map to pick out their actual names. There's a lot of interesting things going on here behind the scenes. Like, for example, if I do Command K, Command I on this guy, Command K, Command I, like it has worked out that it's of type staff member. So again, it's kind of following the flow of execution all the way through from a type point of view. It's following the types all the way through, and it's getting it right. Down here, as I'm creating this code, when I go staff dot, where's my dot? These are the only valid options that are available to you. Again, the compiler is helping me to get it right and not put anything silly in there. Equally, well, here I'm actually invoking my get staff names, and if I try and put something here, right? Let me just get rid of this, and I start my typing. Again, it's helping me. These are the only valid departments that you can meaningfully pass as a parameter. So they're all the really nice kind of sometimes unseen things with TypeScript as you're developing code. So it's very developer friendly in that sense. How are we on time? Well, thought I'd be further, but anyway. Generics. Something we love in software engineering is reusability. We love writing code that we can reuse. That's what classes do. That's what functions do. But what generics allows us to do is to define components where, and a component here now could be a class, it could be a function, could be a data structure. Define components where the data types that are being used in the component are variable. We can specify a different type or types for the variables kind of at execution time. Like when we talk about variables, we talk about assigning a value to a variable. But here with generics, we're able to assign a type to a variable. And so whatever the nature of the component is, it's actually going to be reusable for different data types. Generics is not certainly something and you may have come across it in other languages because it's certainly not unique to TypeScript. I think it goes way, way back to probably C++. It would have been the first language to use this concept of generics. You may have seen it in Java. It's certainly in Kotlin. In fact, a lot of you have done Kotlin, so that's where you would have seen a lot of it, whether it was pointed out to you or not. Now, in TypeScript, which is very like the syntax in other languages, actually, how do we indicate that generics is at play here? So here, just quickly talk through this and then I'll stop. But here I'm actually using generics in relation to a function. Now all the names are useless, but so my function is called process, and it's this syntax here, angle bracket, close angle bracket. So T here is what we call a type variable. Type variables, by convention anyway, in TypeScript tend to be single letter capital letters. Okay, but there's no requirement to follow that style, but that is the style that has evolved from a convention point of view. So T is actually, it's a variable, but it's a variable that's going to be assigned a type when we actually want to invoke this function. The function takes two parameters. The second parameter is a number, but the first parameter, its type is T. We don't need to worry about the actual processing done by our function. So to actually use that function then, here I'm using it. And when you want to invoke the function, that's when you kind of bind an actual type to T. Here I'm binding the person type, which I presumably have defined somewhere else, either using type aliases or an interface data type, which means that person X, that parameter, that will have to be an object of type person, otherwise the compiler will complain, and second argument is okay. I'm reusing the same function here, but this time I'm setting T to box, and presumably box X. or box y is a variable of type box. So these are this is a declaration of a function using generics, and the function can take different data types. Now, in reality, it won't work for every data type. There are certain constraints on what types you can assign to T. I'm not going to go into it, but there would be in real life. Here we're actually invoking it and we're binding a type to our T variable. Okay, so there's an actual example that I show you in the code, but we ran out of time at this stage, so I'll freeze it there. I have you on Thursday anyway, so we'll finish it off on Thursday. In terms of the lab, if you have started the lab, I don't know if you have or not, but you can go a little bit further in the lab as a result of what I've covered so far. So, you can do the functions, interface data types, functions, optionals, type aliases. We haven't covered enough on generics yet, and we haven't covered utility types. So we'll cover those two on Thursday, and then you'll be able to complete this lab and you can submit it. I think I said next Monday is the submission date for the lab. Okay. Are there any questions that anybody has for me?
No,
Sorry, go ahead.
no.
Oh, no, sorry. Okay. That's fine. So I will have a lecture on Thursday and I'll meet you in the lab on Friday. Thanks a lot.